tools that give the end user, so our customers' customers, the ability to understand how much time do I have left on this drive? How's it behaving? What type of failure modes is it experiencing? How many errors are being corrected? And so all this stuff is reported out real time. And the great thing is it gives you this dashboard to understand that, okay, great, I've got 10 years before I need to do any maintenance on that drive, or I've got 5 years, or I have 5 days, and you can pick your spot. And the one thing that's interesting is that seems to be a lot more comforting for our customers than a hard disk drive failure, which are generally unpredictable. Right? They're generally mechanical in nature, and it's something that's induced a mechanical error, and so they're pulling drives and performing diagnostics after the fact. These are more predictive, forward-looking, proactive means to measure the utility and the vitality of the drives in the systems. The other thing is, and you'll notice on the different SSDs that are out there today, there are different capacity points. Your conventional capacity points are going to be some multiple of 8. So NAND generally will be sold in 32, 64, 128, 256 type capacity points. Our enterprise drives are actually formatted differently. So there's underlying NAND that we've effectively over-provisioned. And based on the endurance requirements and the I/O requirements, we can vary that and toggle that. And so we've identified across our different tiers of products different capacity points that we think render the best balance of available stored capacity, over-provisioning, and things of that nature. So that's also something that needs to be part of an enterprise class SSD as well. So there needs to be some element of over-provisioning going on. And then what kind of goes into achieving the performance is how do you manage your striping basically within the system, within the drive, to work around the performance limitations of the NAND itself. So there's a very complex data management and managing all these different channels of NAND that are happening in parallel, which is entirely a firmware-based exercise. So these two kind of spheres are really speaking to how you get performance and reliability optimized within one of these drives so that they can endure these types of workloads. So now we're going to drill a little bit deeper into each of these different elements here and look at kind of the critical building blocks of what is an enterprise class SSD. So at the heart of it, we mentioned that we do all of our own proprietary controller design. It's all of our own firmware. That is what we view as the engine. So that critical silicon, which is managing all the host interface protocols, as well as managing all the back-end media management functionality. And I would say, even if you look at like a budget of gates in terms of what we have to allocate for the different functions in terms of interface protocols and back-end, roughly 90% goes into back-end. So that speaks to the complexity of what's happening on the back of the drive. And it's really interesting because when you hear the commentary from, like, say, a Seagate who's kind of trying to get into the market as well, and they'll talk about, well, we know the front end, we know interfaces. Well, we contend that knowing the interface is a commodity, right? Like you have to know that. That's your cost of getting in. The real design challenge is, what are you doing on the back end? How are you managing the media? Do you understand the media? Do you understand how to deliver the performance, maintain the reliability, and do everything that we mentioned on the previous page? And that's really the essence of what goes into this SSD engine. And then as you kind of go up in these these different concentric circles here, you go into the system level design. And so we mentioned that you've got different memory technologies within these products, and that may even evolve over time. I mean, there's some interesting emerging technologies on the horizon, such as phase change and other type of memory technologies that may also introduce some interesting design benefits that we could bring into our technology. But we look at all that. And then there's also the power management circuitry, which we'll talk about in a moment. And then there's the manufacturing process itself. Okay, so we vertically integrated on all these dimensions because we know that this is what our customers need controlled. Okay, so we control every step of the way, and we'll talk about the elements that go into the testing and the customization for products as well. So first, let's drill into the engine. So we talked, this is that controller piece, the front end, whether it be an ASIC or FPGA. It is the critical, brain and nervous system for the entire drive. So that's managing all the host interface protocols and doing all of the media management. So the foundational elements are, the hardware. And what you try to do in hardware is effectively create a lot of channels back to NAND. Okay, so striping becomes really important to get the performance that you need out of these drives. We've done a lot of controller ASICs over our decade and a half, roughly, of doing solid-state drives. So there's a very mature, complex process and approach to designing the controllers that go within our products. And we talk about, we've got products out there today. There's nobody else that's been shipping. We've been shipping now for about a year and a half. Our Zeus IOPS product, which has 16 channels in it. A lot of complexity associated with that. Our future generations of products will be increasing that. So the hardware piece is pretty important in itself. The software piece is the critical one. Okay, so we've already kind of talked a little bit about kind of some of the design challenges you have around the software and firmware that goes into the product. We talk about being IOPS optimized, and we even classify our products as being IOPS optimized. That is a very complex approach to designing solid-state drives. And it drills all the way down into the lowest level file system, or what they call the NAND translation layer, that is managing what our host access is to actually what's happening with the media in the back end, how we're writing to the NAND and how we're reading from the NAND, and how we're balancing those as the host is demanding reads and writes virtually simultaneously. So that creates a lot of complexity for the controller architecture. We are doing a lot of things in controller and architecture to mitigate the write amplification that we discussed. So we've got unique proprietary approaches to what we call serializing the data. So you can get a lot of random writes from the host that, if we just pass those through to the NANDs, would induce a massive endurance penalty to the drive. What we're able to do is, for both speed and endurance improvements, we can serialize that and basically buffer the writes so that they don't thrash the media and basically bring up endurance issues before their time. We can extend the life of the media as a result. So I mentioned that we're doing a lot of striping of the LBAs across multiple NAND devices within these products, and there are a lot of them. We're the only company today who's shipping in mass production 0.5 terabyte SSDs today, so that's a lot of capacity, which means there's a lot of NAND devices in there. There's a lot of complexity in the way in which we're managing all those different NAND devices. We talked about the enterprise-centric transfer sizes, the long blocks of 520s, 524s, 528s. You also must implement what's classified as full data path protection, which is a data integrity guarantee, which basically means that anywhere that data goes, once it comes across the interface to the drive, it is fully protected, which means you will never have any data corruption issues once data goes into our drive. And that's even the case when power is removed from the drive. Okay, so full data path protection is something that nobody else in the industry has implemented today. And I highlight some of these things because I think a lot of people kind of scratch their heads and they try to understand, well, why can't some of these other drives work in the enterprise? Well, I mean, these are like your minimum requirements. These are your minimum functionality feature sets that need to be within the drives that are all enabled in this complex, proprietary, patented, proprietary systems that we have in all of our code that goes within all of our SSDs. Okay, so let's go into the system level design. So, one step up from the controller, you start to look at, well, how do you design these systems? I've already mentioned that you need to have local memory within the drives in order for them to be enterprise ready, to achieve everything you need out of the code that we talked about in the previous page. So thus the volatile memory. The volatile memory, by the way, becomes very helpful in this write buffering and serialization process as well, which ultimately enables us to write data in a serial fashion back to the NAND rather than in a random fashion. And then this power sustainment system, the power monitoring circuitry, all needs to be resident within the drive as well. And what that does is that protects the non-volatile memory if in the event power is removed from the drive. So we've got built on board power circuitry that serves as a backup to make sure that any data that resides within that DRAM is moved back into the NANDs, so that any data that's in that volatile area is fully moved into non-volatile memory. Let's go up one more step into the SSD manufacturing process. We're firm believers in the fact that this needs to be a vertically integrated piece of our business. We do all of our manufacturing. We'll talk about where that happens in just a moment. But the manufacturing processes are very specialized. And this whole kind of concentric spheres thing is it's a feedback loop too. Okay, so what we've learned in our it's over 14 years of doing SSD for these high reliability segments is that There are unique approaches to manufacturing. There are unique approaches to test. There are unique requirements from customers, which all need to be enabled at the controller level. Okay, so it's the application knowledge that helps our chip design. It's our chip design which helps us on the qualification, and it's this great, vertically integrated feedback loop. And so when we talk about why we have to invest in manufacturing and why we've got these optimized systems and processes for manufacturing, is because we've got hooks built into our product that help us manufacture reliably and the volume and the capacities that we're doing today, right? So there's a lot of complexity that goes into manufacturing these half a terabyte drives or 256 gigabyte drives, very high capacity, high reliability drives that we're manufacturing. So we've got extensive experience there today, which we think affords us a great advantage. In terms of that, where that happens, I want to kind of give you a sense of where our manufacturing takes place. So our headquarters is in Southern California. We've got 2 primary manufacturing sites. We've got offices really about the globe. We're doing R&D in 5 different design centers about the globe. We've got 2 primary manufacturings, or manufacturers really 2 locations, our Malaysia campus, and then in Southern California as well. This is really going to be the backbone of our operations. As you already heard, our mix in terms of how much is being manufactured there is increasing rapidly. To give you a sense of that scale, we've got the ability to ramp up Malaysia to well over 4x where our Southern California facility is today, which gives us the ability to get to volume. And this becomes important when particularly you start to deal with the lower end of the spectrum. You start getting into, like, say, Mach 8 IOPS for general purpose servers. Well, hopefully that becomes a much larger category in terms of unit volumes on a monthly basis or annual basis, whatever your period of time may be. And our customers want to know that we've got the ability to scale. And so is the case for the design we have with Dell and their mini ultra mobile PC. How do we make sure that we've got the infrastructure that can scale when these product categories become much larger? And so we're investing in that right now. And again, those are all tuned and optimized for what we see as critical elements of manufacturing SSDs. So high volume, cost effective, and high reliability SSD manufacturing. Now testing, I would contend, is probably the area where we probably have nearly as much, I would say, unique IP and proprietary approaches to testing as we do to chip design within the controllers as well. And again, I think a lot of this is a function of the fact that we've been so focused on high reliability SSD for so many years. We've learned a lot about ways to do it. We can't be dependent upon commercially available systems because there's nothing out there today that we think is right for testing manufacturing systems to the levels of reliability that our customers expect and the volumes that our customers expect. So all these, and I've kind of taken a snapshot of our SSD testing systems, and these are all chambers that actually do dynamic temperature testing of every SSD that gets shipped. We've kind of talked about some of the critical process steps that go into what we refer to as our embedded flash or embedded media tests within every drive, which, by the way, is enabled by unique controller technology. So again, we're building the hooks into our silicon to enable unique approaches to test, so that closed loop, vertically integrated approach is really important to enabling what our customers need and demand out of test. So we are running extensive, sometimes multi-day tests as a manufacturing step in our processes. Okay, so doing these real high capacity drives, when we're doing write, read, compares on each physical block within the drives, takes a lot of time. And we don't cut any corners on that stuff because, again, these products need to be designed and need to be ready to be utilized in the highest end mission critical systems out there. And so in the process, we've been able to do a very cost-effective test process that optimizes the DPPM or the reliability metrics that our customers need. So testing is a really important area. And by the way, if you're ever in the Southern California or Penang area, we'd be happy to give you a tour of the facilities, because I think it's pretty interesting and enlightening to see these systems. You can kind of look inside them and see where, there's STEC silicon content within these systems. So we built the intelligence and the engines that basically run these test systems is all proprietary silicon that we've designed as well. So there's a lot of interesting innovation that's happening around tests as well. And then the final portion here is what we do. Oh, you want to take a?
Pat, why don't we take a 5-minute? Is
Perfect.
This a good break point?
Yeah.
Maybe take 5 minutes, kind of refresh, and then we'll come back.
So I've got 10 o'clock. So 10:10. You want to say start at 10:10?
Yeah. Sounds good.
Okay.
Okay. And everybody too, if you haven't signed our little guest book, if you please do so. I'll just put it up at the front. Also, I'd like this Zeus IOPS, I'd thank you for returning it. If someone hasn't seen it and wants to take a look, Manuch hasn't known this, but I know it's made for a huge enterprise storage system, but I've been using it in my laptop, and now the truth comes out. And seriously, let's have a little break, and then we'll come back and finish, and also Q&A and demo.
So Mitch, do you want to kick off the next session? I'm mic'd up.
The next couple steps. Everybody, would you like to take your seats, and we'll continue on? What we're going to do from now is Pat's going to continue through the rest of the presentation. It's probably another 20, 30 minutes on that. Kind of in your head, or jot down your questions and things. After Pat concludes, though, what we're going to do is he's going to walk you through the demonstration of Zeus IOPS, performance-wise, compared to, and then it's all set up back there, compared to the 15K rotating hard drives that you'd find, for instance, in a symmetric system or high-end performance storage system. And so you can kind of see for yourself in terms of IOPS, performance, and some of the other metrics that Pat and his group used to measure. After that, we'll do the Q&A. So be glad to answer your questions. So please write them down, keep them in your head, and we really will be glad to spend the time and the attention to answer them. That's part of the value of this. You go back with your questions answered, and they're probably some of the same questions that your colleagues and peers in the room would probably want to ask too. So those are the kind of questions that need answering. Pat, let's get going.
Ready? Okay.
Thank you.
Ready. Yeah. Thanks, Mitch. Yeah. Great questions. I think the exchanges have been exceptional. So. Hopefully what we'll do is we'll probably do like another 30 minutes of kind of one-directional presentation. We'll conclude with an overview of the demo as Mitch sent, and then we'll open up to Q&A for the whole group. So just want to conclude on the facets of the business model that we believe are creating some differentiation. And remember, these are definitely the kind of obligatory elements that you need to have in place in order to support particularly enterprise. So the final piece of this all is customer delivery, customer support, infrastructure to enable the qualifications. As we mentioned, we're effectively in sole source situations with every major enterprise OEM. Some are through qualification, some are concluding qualification. We expect everyone to be fully through qualification within a quarter or two. So it's kind of a universal blanket statement that we're addressing the unique needs of all these customers who all want their own unique versions of firmware. They want products optimized for their unique code that they have. And at the same time, we're trying to take a relatively new technology, and while the interfaces are similar and standard to what you have in hard disk drives, there are other elements of operating systems and file systems that mandate changes either on the host side or on our side. And so there's always this kind of ongoing collaboration that is with our customers. So when we're going through qualification, it is an intensive effort. And I think in many ways you can take lessons from the way the hard disk drive industry is, where you've got very capable hard disk drive companies, the likes of Toshiba, the likes of WD, who effectively just do not play in the enterprise and have not played, particularly on the 15K fiber channel side, because there were barriers to entry beyond just the media and the heads that were at the end of the day prohibitive from them addressing those market segments. And so we think as well, just the burdens of supporting the enterprise enough can bring organizations to their knees. So you need to understand what that's like before you get into the business, and you need to make sure you got the organizational recipe and building blocks in place to address their unique needs. So let's kind of conclude the technology section with a little forward-looking view in terms of what you're going to see from us next, at least in terms of a general sense. And there's three facets that really govern and serve as our design principles and guidelines, and that's continue to increase the performance. And these are based on just echoing what our customers are saying they need from future generations of technology. Continue to increase the performance, and it's performance where it matters, right? I kind of talked about how it's got to be bidirectional, fast reads, fast writes, bandwidth-wise, and I/O-wise, okay? So continue to push that vector. At the same time, you have to continue to sustain high reliability for the enterprise. All the while, the native media itself is going through iterations of declining reliability. So you've got this kind of counterbalancing act that becomes a burden for the controller to deal with media issues that are going to make it difficult to achieve both these, right? So performance and reliability are getting more challenging with the future generations of memory technologies. So it puts a big burden on the controller to offset that. And then the other is continue to drive costs down. So those are really what you can expect to see from us on a go-forward basis, future products, and everything that comes out from us that you'll see in 09. We'll have some pretty interesting product come out in 09. They're going to be basically addressing everything you see listed here. A little update, we basically been showing this table on an annual basis, just what are we doing in terms of creating the patent fortress, if you will, to protect our technology, to make sure that this was still a massive time to market advantage and technology advantage today. How do we make sure that we can capitalize on that? We're expending considerable organizational resources in moving all those enterprise OEMs through qualification. So again, how do we capitalize on that opportunity? It's to make sure that we've got strongly fortified positions within these different applications, within these customers, and then also down to the fundamental technology level to make sure that we're building out around the critical facets which enable enterprise SSD performance. So you can kind of see everything from the nuances of SSD performance to data integrity and the full data path protection and reliability, to endurance metrics, to ways to optimizing different types of media within the drive, different small form factors of SSD, the chip stacking that we implement on our products, unique IP we have around network storage methodologies, which filter down into our product, and then also other related technologies around other memory technologies too. So areas that we view as a fairly strategic patent portfolio, and this is an ongoing effort for us. So every year this is going to continue to get stronger and stronger.
One key point to point out here is that as we are the early player in this market, we're hitting a lot of technological challenges on actually making our products work in customers' applications or improvements to the products on how they should work in these applications. And when we come up with solutions, every one of those are getting patented as well along the way. So the next guys that are coming on, they're going to be hitting the same challenges, and then they're going to have our patents to deal with.
Okay, so what do we want to do in terms of concluding this section was just pull together everything we've discussed previously about which technologies make sense, and then kind of put that out there in terms of how that compares against the others. Because I still believe, and I mentioned this previously, but I still believe that there's this kind of belief that as soon as someone brings an SSD or so much as announces they're going to do an SSD, people just give them credit that they're going to have all these different things addressed. Well, we've got a couple folks who are in the market today, not even referencing those that aren't. We've got a whole bunch who are trying to get into the market or saying they're in the market. I mean, I always love to kind of debate with folks like, how many companies are doing SSD? Well, it depends on what you mean by doing SSD. It's one thing to just simply take a bunch of NAND together, go buy some commercially available controller and say, voila, I've got an SSD. It's a different thing to actually design this stuff in, ship it in volume to a global OEM, and even make it through the qualification process. And it's in ways it's kind of interesting to watch what happens if you just go through like a standard RFI process, request for information, or kind of the early vendor assessment process with a Dell or an HP or an IBM or one of these major global OEMs. And you'll get 100 people piling into that thing. Everyone's going to respond and try. And I tell you, the first hurdle clears out 99% of them. And over that first hurdle comes really the folks you see here. Really, it's just these two. Really, we would kind of say in our minds, STEC is certainly leading the charge in the enterprise. Samsung's done a lot around a notebook drive. Intel maybe because they're relatively new, but we don't really ever run into these guys. And then all the others who say they're doing it, we definitely they don't make it over the hurdle. So we've kind of listed the different companies who, even if for no other reason, just because their scale, I think a lot of people give Intel credit that, hey, well, they'll probably be good at SSD at some point if they're serious at it. So we've listed them here just to kind of give you, some comparative, metrics and look at, who is doing what. We've kind of walked down some of the, the general things like, years of focus around this category of product. You can see, decade plus compared to some of these others. experience and productization around SCSI interfaces. So we talked about our SaaS product. I have one of our SaaS products here. We can take a look at it if someone wants to kind of see what that product looks like, by the way. But we've got a history of doing SCSI drives for the military, for the enterprise. So there's a lot of heritage there. Fiber channel drives, we're on our 3rd generation of a fiber channel product right now. So there's a lot of experience around these complex enterprise interfaces, whereas our competition has done none of that. Our competition definitely does SATA, right? So SATA is going to be the high volume, the low cost mobile interface of choice. Okay, so it probably comes as no surprise that that's the entry point for these guys. High volume, looking for a place to move a lot of NAND. They're manufacturing the NAND. They need kind of relief valves for all that NAND. So they're going to be very focused around SATA SSDs. And if you can make SATA work in the enterprise, which it effectively it really does not, aside from maybe some of the unique kind of boutique boot type applications. The fact is, even though in the enterprise, you've got this nearline SATA category of hard disk drives coming out, that's a capacity play. Okay, that's not SATA for performance. Like if you look at what Sun has done, Sun basically says we don't need 15K RPM drives anymore. Those things are dinosaurs. If you talk to them about it, their philosophy. Call it what you want. I'm not saying 15K drives are bad, but Sun's approach is SSD and then SATA, right? So SSD for performance, big SATA drives, cheap and deep, spinning media, terabyte, low-cost nearline SATA drives. Okay, so SATA SSD in our minds really does not make sense in the enterprise because it doesn't address terabyte capacities. SSD is for performance. So if you're looking at the enterprise, SATA SSD is not your solution. It's some type of SCSI. It's going to be fiber channel and SAS. So that is critical to really understand and also to have in your arsenal today as all these enterprise OEMs are getting to market around qualifications. So, and then also, some of them mentioned the facets that I mentioned earlier, the full data path protection. We're the only company doing full data path protection, and it's obligatory for the enterprise. You cannot use a drive, a hard drive, or an SSD in the enterprise unless it has things like full data path protection, the long sector supports, the 520s, 524s, 528s. Nobody else is doing that stuff. So a lot of people kind of ask like, well, these competitive dynamics isn't Samsung doing SSD? Well, yes they are, but what they're doing is really different from what we're doing, and even roadmap-wise, like these guys are, well, at least Samsung's showing a roadmap which kind of looks at future generations of technology. This type of stuff really, the enterprise type interfaces, the enterprise class of products is not addressed. And then there's just the track record around successful SSD qualifications, OEMs in qualifications, shipping volume products in the market. Obviously, we're there already. We talked about the fast, predictable latency, particularly write latency, by the way, which is very difficult to attain with a flash-based drive, and then the sustained I/O performance as well. Okay, so I do want to emphasize one more time that predictable, consistent latency and I/O is very important, and we'll show you how some drives behave when we do our demo, and you can see how some are doing that and some are not. So hopefully that kind of gives a sense of kind of comparative capabilities, features, and things of that nature to kind of tie all the different technology elements together. Okay, so now we're going to move into the demo. So what we'll do is we're going to bring some of that information up to the screen here and talk about what's happening within these demos. Okay, so what we've done is we've created 2 demos. Actually, Raf, if you could go to the other demo machine, we'll start with the other one first. So this one actually is looking at our Mach 8 IOPS class of product. And what I want to do is I want to show, oh yeah, sorry. So thank you. All right, so the switch is in the back. If you want, we can manage that from now on. So Mitch, is it number 1 is for the number 2 for the one on the right? Is that right? Okay, great. So Mitch, we'll go to number 2, and if you look on there, you'll see number. Yeah. All right. So this is looking at our Zeus IOPS product, so the fiber channel product we sent around, fiber channel SAS type products, and again, I think it's important to point out here that there's nothing like this on the market. Okay, so there's no point in even comparing Zeus to some Intel stuff or to some Samsung stuff because they're in different leagues. Okay, so what we've done is we've taken 30 Savio drives. Okay, so the fastest I/O drive, spinning drive out there in the market, and we're running them side by side. And so what the dials are showing here basically is kind of in a speedometer fashion is IOPS. Okay, so keep an eye on that, and then also we're plotting here is so that you can kind of maintain some sense of continuum is how they compare. So again, on the left side is your Savio drives, on your right side is the Zeus, and you have a kind of historical perspective. Because what we're doing, if you look across the top, is we're running different type of application scenarios on these. So because it'd be very easy, actually, I could configure a system with a bunch of kind of notebook class of drives, so like a Samsung and Intel drives, and if I just showed you fast sequential reads, guess what? I could beat Savio drives as well. But if I showed you writes, the whole thing would fall apart. Okay, so it's really important to appreciate how difficult it is to get fast write performance, and then also mixing it. Okay, so mixing it real time. And just to give you a sense, by the way, I'm going to show you a little bit about the demo here, so you kind of understand what is going into the demo. We are in both the Zeus versus Savio comparison and the Mach 8 versus the other drives. We're running a SQL I/O database deployment. So it's actually running a real file system. So it's not just Iometer, which is more of a benchmarking utility. It's actually running a file system and the database as well.